Good morning, students. Today we are going to learn here the first chapter, forces acting on a particle. So before that, we will see here some preliminary part. Yes, some basic definitions of these forces acting on a particle. So the first is what is meant by a particle. So you know what is meant by a particle. Particle is a body which is indefinitely small. Yes, it is indefinitely small in size and shape. So it may be considered as a geometrical point which has a position and a mass. So I think all of you clear the definition of a particle. Particle means it is a very tiny small size and also shape. Yes. So next one is what is meant by rigid body. So it is a system of particles. The distances between remains unchanged. It means that a rigid body may also be regarded as a continuous distribution of a matter. Yes. So this type of concept is called as a rigid body. So next one is a force. So you know the definition of a force. So it is a cause which changes or tends to change the state of the rest of uniform motion of the body. A force has a point of application, that is the point of the body at which the force acts magnitude and direction. Yes. So it means that if we apply some magnitude and direction of the body, then that is called as a force. Yes. So from the geometrical point of view, a force can be represented by a directed line segment. It is called as a vector through the point of application, and this line of segment is termed as its line of action. Next definition is equilibrium. A system of forces acting on a body initially at rest is said to be equilibrium if the body remains at rest under the action of that system. Yes. The next definition is axiom of a equilibrium of two forces. So the two forces acting at the point of a rigid body are in a equilibrium if they are equal in magnitude and opposite in direction. So these are again some basic definitions you can write here. Already I have given these definitions. Yes. So this is the definition of resultant of two forces. If the system of forces P1 bar, P2 bar and P3 bar acts as a simultaneously upon a rigid body and there exists a single force, so this is called as a resultant of a forces. Next one. So we will see here the law of the parallelogram of a forces. So what is this law? If two forces acting at a point are represented both in a magnitude and direction by the adjacent side of the parallelogram drawn through their point of application, so their resultant is represented by the diagonal of the parallelogram passing through that point. So are you understand what is the meaning of this law of parallelogram of forces? So if two forces acting at a point, दोन forces जर एकाच पॉइंट वरती जर आपण अप्लाय केली, so both it is magnitude and direction by the adjacent sides of the parallelogram drawn through their point of application, then their resultant is represented by a diagonal. So we can see here in this figure, it is the diagonal, it is represented, yes, of the parallelogram passing through that point. So that we have to show. So see here the proof of this theorem or this law. Let we can assume here P bar and Q bar be the two forces acting at a point O. Here if this P bar and Q bar, these two forces acting at a point O, then this point of application and it is represented in a magnitude by adjacent sides, this OA and this OB. Yes. So this complete parallelogram is OA, C and B. So are you seeing here in this figure? Then the resultant, so by applying this one, this statement, the resultant R bar, so this is the resultant R bar. So you have shown here in this figure. So this resultant R bar of the forces P bar and Q bar, it is represented by a diagonal vector, and this vector is OC bar, this one. Yes. Suppose that OC bar is P bar. Yes. OC bar is Q bar and this OC bar is R bar. So here I think it is something is wrong, because it is not OC bar is P bar. So here P bar is OA bar and this Q bar is OB bar and this one OC bar is R bar. Yes. So that resultant R bar is the sum of the two adjacent sides P bar plus Q bar, and it is written here R bar is equals to P bar plus Q bar. It means that it is OC bar is equals to this OA bar plus this OB bar. Yes. Therefore, this OC bar, this one, you can write OA bar plus OB bar. Yes. So it means that, what does it means? So it means that their resultant is represented by a diagonal of the parallelogram passing through that point. So yeah, is that clear? Are you understand what does it means? This is the law of parallelogram, and the proof is also given here. Next one is, so this is the question. Determine the magnitude and direction of the resultant R bar of the two forces P bar and Q bar acting at an angle theta. What we have to do? Here we have to find out the magnitude and direction of that resultant R bar, which is acting at an angle theta. So the solution is, you know the law of parallelogram of a forces. So let the adjacent side OA and OB and the parallelogram OACB, which is already given in the previous figure, represent the forces P bar and Q bar acting at an angle theta. Now you know we can write that representation of this R bar means this is the resultant vector R bar is equals to P bar plus Q bar. So call this as 1 or 2.1. So if you see here, this is shown here in this figure. So by multiplying the equation number 1 or 2.1 by R bar, we get R bar composition R bar is equals to this one. This is the multiplication. So just you can simplify it, we get this expression. So this implies that R bar modulus of R bar square is equals to modulus of P bar square plus 2 into P bar composition Q bar plus mod of Q bar square. You know P bar composition Q bar is equals to Q bar composition P bar. So this is mod of P bar square plus 2 times P bar Q bar is cos theta plus mod of Q bar square. Yes. Hence we have this R is root of P square plus Q square plus 2 times PQ cos theta. So this gives the magnitude of R bar. So though in previous figure we see C draw CM, which is perpendicular to OA, it is produced. So therefore the angle BOA is equals to angle CAM, and which is theta. Suppose the resultant force R makes an angle alpha with the direction of P bar, then from the right angle triangle CMO we have this formula, tan alpha is equals to Cm by Om, which is equals to Q sin theta by P plus Q cos theta. And so this implies the value of this angle alpha, which is equals to tan inverse of in bracket Q sin theta upon P plus Q cos theta. So this gives the direction of that resultant vector R bar. Next one, So this is the remark. If P bar is equals to Q bar, that is the magnitude of two forces P bar and Q bar are equal, then we can write R bar is root of P square plus Q square plus 2 times PQ cos theta is equals to, you can write just it is root of 2P square 1 plus cos theta, and which is equals to root of 4P square cos square theta by 2. Yes. So this implies the value of R, and also you can know this tan alpha, just you can simplify, we get tan of theta by 2. And so it is given here, the value of alpha is theta by 2. That is, the line of action of the resultant force R bar bisects the angle between two forces. Yes. Next one, again this is the second remark. If theta is 0, it means that when two forces P bar and Q bar act along the same straight line and in the same direction, then R bar is root of P square plus Q square plus 2PQ, because cos 0 is 1, here theta is 0, that's why this cos 0 is 1. So this is equals to root of P square plus Q square, which is equals to P plus Q. If theta is 90, means pi by 2, when two forces P bar and Q bar are act at right angle, then what is R? R is root of P square plus Q square. Here cos of 90 is 1, and that's why tan of alpha is Q by P, and this implies alpha is tan inverse of Q by P. If theta is pi, so this is the fourth remark, that is, when two forces P bar and Q bar act along same straight line but opposite in direction, then R is root of P square plus Q square minus 2PQ, so cos pi is minus 1, so this is equals to root of P square minus Q square, which is equals to P minus Q. So in this way you can find the angle. It depends the resultant vector, if the theta is pi by 2 or theta is 1 or theta is 0. Yes. So this is the next example we will see here. Find the magnitude and direction of the resultant of two forces whose magnitude are 8 kg and 7 kg respectively at an angle of 60 degree. So we have to find here the magnitude and also the direction of that resultant vector. So we have P is given here 8 kg and Q is given here 7 kg and theta is also given here 60 degree. Now we have to, the magnitude of resultant is given here. R is equals to root of P square plus Q square plus 2 times PQ cos theta. So P is 8 square plus 10 square plus 2 into this, you can put the value of this P and Q here, and cos 60, and cos 60 is 1. So this is just, you can add root of 169, and square root of 169 is 13. Thus the resultant R is equals to 13 kg. Now we will see the direction of that resultant vector. It is find out by using this formula. Alpha is equals to tan inverse of Q sin theta. So Q is here 7 sin 60 upon P plus Q. So P is here 8 plus 7 cos 60. Just you can simplify, we get that alpha is equals to 30 degree. Now this is the second example. Find the smaller force when two forces act an angle of 120 degree. The greater force is 30 kg and the resultant is perpendicular to smaller one. So here solution is given. Just you can solve this example at home. Today we will stop here. Yes. So I think all of you are clear these concepts very clearly. Yes. Thank you.